What did the James Webb Space Telescope find at the edge of the universe? Why are scientists so excited? We invite you to join us and explore how this telescope discovered something very important at the end of what we can see. If you want to be updated about the world and its surroundings, subscribe to our channel. Enjoy this video and turn on the notification bell. Albert Einstein developed the theory of time, which changed Newton's theory and applied it to the universe in 1916. This theory showed that the universe could not stand still and move, expand, or contract. In 1929, astronomer Edwin Hubble discovered that galaxies were moving because of the Big Bang. This is the expansion of the universe. The distance between the galaxies continues to increase. Einstein's theory can easily explain an infinitely wide universe, a universe that curves inward like the surface of a ball on the higher side. Some say that the universe has benefited from its birth in the Big Bang 13.82 billion years ago. Therefore, we can only observe galaxies whose light has traveled less than 13.82 billion years to reach us, forming the space of the universe we call the universe. Visible.in fact, the universe is 92 billion light-years wide, and the boundary of the visible world is the sky, which is the same as the ocean. We know there are infinite galaxies out there, but their light has yet to reach us. Can the James Webb Space Telescope see the edge of the universe? This instrument, which is 100 times more powerful than Hubble, can detect the low infrared light from the early galaxies, planets, and other stars and their existence. However, we still don't know what the telescope will see as it approaches the edge of the universe. The world is divided into the visible and the invisible. The visible is all that we can see by seeing radiation with our eyes, and the visible region is the microwave background, 13.8 billion years old. At that time, the world was opaque, like a thick fog. Some experts believe that the cosmic waves and neutrinos come from more distant places, although this cannot be determined due to a lack of technology. World experts say that in order to better understand the world, one must remember that what we see is only a small part of a larger world. Searching for galaxies like Abell 2744Y1, which lie at the very end of the universe, will help us better understand this fact. Despite the distance of this galaxy, the Moon took 13 billion years to reach us, and scientists discovered it in its infancy, about 650 million years after the Big Bang. The Spitzer, Chandra, and Hubble telescopes worked together to discover this galaxy, as each used a different part of the light spectrum to capture data. By combining data from the three telescopes, astronomers can study galaxies 100 times more distant than those telescopes can observe alone. Astronomers from the Institute of Astrophysics of the Canary Islands and the University of La Laguna used the Hubble Space Telescope to find the galaxy Abell 2744Y1 and calculate its distance and number of stars using the Spitzer instrument. They also used the focal plane method, which is like a magnifying glass that focuses light from distant galaxies to galaxies closer to Earth. This galaxy is small compared to our Milky Way, about 2,300 moon-years across, but it is forming stars 10 times faster than the Milky Way. The redshift of the galaxy Abell 2744Y1 is 8, indicating that the light has been pushed to red wavelengths by the expansion of the universe. Before Abell 2744Y1 was discovered, it was the most distant galaxy at a redshift greater than 7. Now astronomers have discovered something even further away, a supernova called DES 16C2NM, discovered through a study of dark energy. Supernovae are large explosions that represent the last gas of a star before it dies. To understand how the stars work, let's look at death. Massive stars burn large amounts of nuclear material in their cores, producing enormous amounts of energy. It creates a powerful force that prevents the star from collapsing. You see a star in the night sky because there is a balance between two opposing forces: gravity, which pulls it in, and nuclear heat, which pushes it out. As the star runs out of fuel, it begins to cool, the pressure drops, the planet becomes more energetic, and the star explodes into a supernova. The process is quick, in seconds. A supernova occurs when two stars collide. Supernova DES 16C2NM is extremely rare and was discovered in 2016 by an international team of astronomers. The star is a Type II supernova, meaning it has reached the end of its life and explodes in a big explosion. This explosion is thought to have occurred 10.5 billion years ago, and its light has reached us for 3/4 of Earth's history. Due to the expansion of the universe, supernovae are much farther away than they are visible to the naked eye. The star DS16C2NM is particularly interesting because it is a dark supernova, meaning it does not emit much visible light, so it is difficult to see. However, it can be seen using telescopes that can detect the infrared light emitted by the supernova. The team of scientists involved in the discovery of DS16C2NM received help from 3 powerful telescopes, including the Magellan Telescope and the Cerro Tolo Observatory. It took 5 years and more than 500 nights of observation to identify this distant supernova, a huge challenge. However, the team's efforts were worthwhile, as the great distance of the supernova will allow them to better study and understand superluminous supernovae and the causes behind these massive cosmic explosions. A supernova explosion of the magnitude of DS16C2NM, or any other Type II supernova, would have significant consequences for the surrounding galaxy and potentially even for the entire universe. This explosion releases an enormous amount of energy, primarily in the form of neutrinos and photons, which would interact with the surrounding gas and dust to create a shockwave that would travel outwards at speeds of thousands of kilometers per second. This shockwave would cause the surrounding gas and dust to heat up and emit a burst of radiation that would be detectable across a wide range of wavelengths, including visible light, radio waves, and X-rays. In addition to the burst of radiation, the explosion would also create heavy elements like iron, gold, and platinum, which are essential building blocks for planets and life as we know it. These heavy objects spread throughout the surrounding galaxy, enriching the gas and dust and providing the raw material for the next generation of stars and planets. All in all, a Type II supernova explosion like DS16C2NM can have a huge impact on the universe and play an important role in shaping the evolution of galaxies over time. By analyzing the ultraviolet light emitted by these supernovae, scientists can determine the amount of matter produced and the temperature reached during the explosion, which is important for better understanding of these events. The difference between this star and Betelgeuse is the type of supernova explosion. DS16C2NM is a Type II supernova that occurs when a massive star runs out of fuel and collapses in on itself, causing a catastrophic explosion. Betelgeuse, on the other hand, is considered a Type II supernova, but is currently classified as a red supernova. As the James Webb Space Telescope looks at the far reaches of the universe, its discoveries are changing our understanding of the universe's history. The telescope provides a clearer view of some of the earliest times in the universe, showing the formation of galaxies, stars, and other celestial objects shortly after the Big Bang point. One of the main questions scientists hope to answer with the James Webb Space Telescope is, what existed before the universe as we know it? Could there be other worlds or clues as to why the Big Bang happened? Some theoretical physicists have proposed the existence of a multiverse, an infinite number of parallel universes in which different realities exist. Although this idea is still a fantasy, it has intrigued researchers and the general public. If such a multiverse existed, it would represent a new level of technological advancement, possibly even greater than the capabilities of the James Webb Space Telescope. Meanwhile, as the telescope continues to look, deeper questions will arise about time itself. Because light from distant galaxies took billions of years to reach us, what we see when we look at these ancient galaxies is not what it is today, but what it looks like. Of billions of years ago, of course, looking back. This understanding opens up endless possibilities for understanding not only the world's past, but also its future. The James Webb Space Telescope's ongoing observations will further shed light on dark matter and dark energy, 2 of the greatest mysteries of the present universe. Unfortunately, the invisible matter that makes up most of the universe's mass, and the dark, mysterious force that drives the universe's rapid expansion, remains elusive. However, scientists hope to find more clues about these mysterious phenomena by studying the distribution of galaxies and the effect of energy on the moon. What if we could map dark matter and dark energy forever? What new doors of discovery will open for humanity? Scientists believe that answering these questions will bring us closer to understanding the end of the universe, whether the universe will continue to grow forever, slow down, or collapse in on itself. In great ease. As we stand on the cusp of these historic discoveries, one thing is certain. The James Webb Space Telescope is just observing the universe. It is rewriting history for our place in it. The more we learn about the origin, creation, and end of the universe, the more we understand our role in the wider universe. It can explode as a type IIP supernova, a less powerful and less destructive type of supernova. Scientists are now looking for more distant supernovae and those that will be discovered in the future. What do you think is beyond the end of the world? Find out in the comments. Don't forget to like this video, subscribe and turn on the notification bell. Thank you very much for watching. See you soon.